Stratified random sampling 5 marks. This method is used for heterogeneous population. Stratified sampling is a probability sampling technique wherein the researcher divides the entire population into different homogeneous subgroups or strata, and then randomly selects the final subjects proportionally from the different strata. The strata are divided according to selected traits of the populations, such as age, gender, religion, socioeconomic status, diagnosis, education, geographical region, type of institution, type of care, type of registered nurses, nursing area, specialization, site of care. According to the weight, age of the sample and proportions, stratified random sampling is further divided into two categories: proportionate and disproportionate stratified random sampling. Proportionate stratified random sampling. In this, the sample chosen from each stratum is in proportion to the size of the population. When viewed against the entire population, the sample size of each stratum in this technique seems proportionate to the population size and the stratum. It is understood that each stratum has a similar sampling fraction. In this technique, the thing that is important to remember is to utilize the similar sampling fraction for each stratum irrespective of the differences of the strata's population size. It is like assembling a smaller population that is particular to the relative proportions of the subgroups within the population. For example, researcher has 3 strata containing 100, 200, 300 population sizes respectively. Moreover, the researcher selects a sampling fraction that is half. Then the researcher should randomly sample 50,000 and 100 and 150 subjects from each stratum respectively. Disproportionate stratified random sampling. In this subtype, the sample chosen from each stratum is not in proportion to size of total population in that stratum. Sampling fractions is the only difference between proportionate and disproportionate stratified random sampling. The different strata have dissimilar sampling fractions with disproportionate sampling. The exactness of this design is mainly dependent on the sampling fraction attribution of the researcher. If the researcher makes mistakes in allocating sampling fractions, a stratum may either be underrepresented or overrepresented, resulting in skewed results. For example, if a researcher wants to study biophysical profiles of nursing students in a college of nursing, which means 100 students from Himachal Pradesh, 200 students from Haryana, and 300 students from Punjab, the research chooses different sampling factors, fractions, and then randomly selects a sample of 50 subjects from each stratum. Merits of stratified random sampling. It ensures representation of all groups in a population. Researchers also employ stratified random sampling when they want to observe existing relationships between two or more groups. Therefore, comparison is possible between subgroups with this sampling technique. The researcher can representatively sample the most inaccessible subgroup. Therefore, comparison is possible between subgroups with this sampling technique. The researcher can representatively sample the most inaccessible subgroups and even the smallest in the population with stratified sampling. This permits the researcher to sample the rare extremes of a provided population. There is a higher statistical precision as compared to simple random sampling with stratified sampling technique. This is due to the fact that the variability within the subgroups is less as compared to the variations while dealing with the entire population. As this technique has high statistical precision, it should also be understood that it needs a small sample size that can save much time, money, and effort for the researcher. Demerits of stratified random sampling. Proportionate stratification requires accurate information on the proportion of population in each stratum. Large population must be available from which to select subjects. There is always a possibility of faulty classification and hence increase in variability.